All right, good morning, everyone. Good morning. How are you guys doing? We are done with ratio, we're done with proportion. Now we have to start with indices. So, good morning, everyone. Let me see how many people are here, who all are here. Okay, okay. All right. So yes, good morning, Jason Sekera. Hello, Rajat Pandey. Good morning, Ashish Kumar. Good morning, Golden Kumar. Good morning, Rajat Pandey. Good morning. Good morning, everyone. All right, let's start. Give the heading. Give the heading indices. Give the heading indices. Right? Great. Now, you must have seen the numbers like 2 raised to the power 5, 2 raised to the power 7, 2 raised to the power 4 by 9 and all. Right? So this power is known as index. This power is also known as index. What is it known as? Index. This power is known as index or exponent or power. So you know already. Power, so you know already, right? So we call this either index or exponent or power, right? And indices is nothing but the plural of index. The writing was awful. Index, exponent, power, right? And indices is nothing but the plural of index. So the plural of index is indices. And in this session, all we have to learn is some laws of indices, so that the complicated calculations get a little simplified. All right. Most of the times we'll be using the calculator, right? Most of the times we'll be using the calculator. We won't go by the laws, or I'll teach you both the methods. You can either go by the law, you can either go by the calculator, whatever suits you. And so let's start, right? So give the heading positive integral power. Give the heading positive integral power. Come on. Positive integral power. Positive integral power, right? A raised to the power n is equal to a into a into a into a into dot 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 into a n times, right? Suppose you have a raised to the power 4, then what you'll do, a into a into a into a. So you did this 1, 2, 3, 4 times because the power was 4, right? Okay, suppose you have a raised to the power 7, then what will you do? A into a into a into a into a into a into a, right? So you did a into a into a 7 times, right? Similarly, you have a raised to the power 9, so this will be 9 times. A into a into a into a into a into a into a, right? So this is known as positive integral power. Integer means a number without a fraction, right? Integer means a number without a fraction. So 4 is without a fraction, without a decimal part, 7 is without any decimals, and 9 is without any decimals, and the numbers are positive. So it's plus 4 plus 7 and plus 9. Eventually we're going to talk about everything. So right now we're talking about positive integral powers, right? So positive integral powers. Positive means a sign before the number is positive. Integral means that the number is an integer, it does not contain any fractional part, and power is because it is in the index or the exponent or the power of the number, right? Now give the heading negative integral power. Negative integral power. That means a raised to the power minus n is equal to 1 upon a raised to the power n. It's as simple as that, right? A raised to the power minus n is equal to 1 upon a raised to the power n. So if you have a raised to the power, say, minus 7, then you'll have 1 upon a raised to the power 7, and then you'll have what? 1 upon a into a into a into a into a. How many times are there? 1, 2, 3, 4, 5, 6 and 7. This is your answer. This is how you calculate negative integral powers. I hope everybody has got it. Say nishten 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 se nishten 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 se nishten nishten nishten. Yeah. All right. Good morning, Rajat, Bhavya, Sakshi, Shivangi, Sakshi, Surya Kumari, Sammedi, Amir, Sakshi. Right. So a raised to the power minus 7 is nothing but 1 upon a raised to the power 7. This is called the negative integral power. And now give the heading 0 integral power. Zero integral power. If the power is zero, sorry, zero integral power, no, not integral, just zero power. Just write down zero power. So a raised to the power 0 is equal to 1. That means any number raised to the power 0 is always equal to 1. Right? So you may have 2947 raised to the power 0. This will be 1. Any number raised to the power 0 is equal to 1. Right? Any number raised to the power 0 is equal to 1. So we did 3 laws. These are not laws, these are general common topics. We did positive integral power. A raised to the power n is equal to a into a into a into a dot 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 n times, right? A raised to the power minus n is equal to 1 upon a raised to the power n, right? So we did positive integral power and we did negative integral power. Again, the number has to be an integer. It cannot be a fraction. Right? It cannot be a fraction and the number has to be negative for this thing to apply, right? And then we did zero power. What is zero power? Any number raised to the power 0 is 1. I hope यहाँ तक किसी को कोई दिक्कत नहीं है. Everybody is understanding this. Yes, Amir Hussain, good morning. Sakshi is saying 9 time. Rasin Sayyed, Nishten, sir. Amir Hussain, sir, आपने स्पेशल क्लासेस में भी ये टॉपिक कराएंगे हैं. अब हम कहाँ देखेंगे? Okay, Amir Hussain. So if you're watching my classes from the very beginning, you follow the special classes thing. This channel is only for non-Hindi speaking students, right? So I'm teaching everything over here also, and I've taught everything in the special classes also. But in the special classes, I've taught in both English and Hindi. But here I'm teaching it in complete English. All right. So whatever suits you, Amir, it doesn't matter. I'm teaching the same thing, what I taught in the special class. It's just that my explanation was in Hindi over there and my explanation is in English over here. Alright, Rasin, good morning. Suraj, good morning. Nandini, good morning. Pushpa, good morning. Pushpraj, good morning. Geeta, good morning. Rasin, yes. Faizan Bhutta, good morning. Aniket, good morning. Sakshi, yes. Rasin, yes sir. Rajat Pandey, yes. Ashish Kumar, Nishten. Aniket, Ani, thank you so much. Faizan, sir, lag हो रहा है. कोई बात नहीं, Faizan ठीक हो जाएगा. Amir Hussain, okay, thank you. Alright, great, great. So now give the heading laws of indices. Now give the heading laws of indices. I don't think whatever we have discussed till now is a problem to anyone. All right, we've barely discussed 3 things, and those 3 things are positive integral power, negative integral power, and zero power. Yes, good morning Shriyanshi, good morning, very good morning. All right, now laws of indices. Write down the first law. First law. The first law is a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. This is the first law of indices. Alright, a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. For example, if you have 4 raised to the power 9 into 4 raised to the power 10, then this would become 4 raised to the power 9 plus 10, and this would become 4 raised to the power 19. That means if the bases are same and they are being multiplied with each other, if the bases are same, this number is called the base, this is known as the index, right? I hope everybody knows this. I already told you about this index, right? The number below this is known as the base. Okay, so if the bases are same and they are being multiplied with each other, then the powers get added. For example, if you have 5 raised to the power 2 into 4 raised to the power 9, can I add the powers over here? Come on, quickly tell me, can I add the powers over here? 5 raised to the power 2 into 4 raised to the power 9. Can I add the powers? 9 plus 2 is 11. Can I add the power? Good morning Shriyanshi, good morning Kavya, good morning Vishal, good morning Push. Sir, Unacademy से फाउंडेशन प्रॉपर मैथ्स के लेक्चर हिंदी स्टूडेंट्स के लिए हैं. मतलब नहीं, not only Hindi. See, this is, I'm not saying this is for English speaking students. This is for non-Hindi speaking students. Those people who don't understand Hindi. These lectures are for those students. In Unacademy CA Foundation Pro, in Unacademy CA Foundation Pro, I teach in both the languages, Hindi as well as in English. Okay? Alright. Very good. So all of you are saying that the powers cannot be added because the bases are not same. So you guys are absolutely right. Powers cannot be added. Right? And suppose we have 99 raised to the power 1 into 99 raised to the power 20. Can the powers be added? Yes, because the bases are same, so it will become 99 raised to the power 21. And if the powers are 99 raised to the power 1 plus 99 raised to the power 20, so can I add the powers? Can I add the powers? It's not the denominator, Kavya, it's the base. You don't call it denominator. Denominator is said denominator. You call the in a fraction, the lower part of the fraction is called the denominator. In indices, when you see a number like this, a raised to the power n, then a is not called the denominator. This is called the base. This is called the base, and this is called the power or the index. All right. Now, quickly tell me, if I have 99 raised to the power 1. If I have 99 raised to the power 1 plus 99 raised to the power 20. Alright. नहीं शालीन, कोई आइडिया नहीं है. ठीक है? 99 raised to the power 1 plus 99 raised to the power 20. Come on, tell me, can I add the powers? Can I add the powers? Come on everyone. 27 people are here. Come on guys, come on everyone. Can I add the powers? If I have 99 raised to the power 1 plus 99 raised to the power 20, can I add the powers? The answer is no. No. We have a plus sign over here. The sign has to be the sign of multiplication. Dude, what the hell are you doing, man? A raised to the power m into a raised to the power n. Then only the powers will get added. If these bases are to be added, 99 raised to the power 1 plus 99 raised to the power 20, then the powers cannot be added. Alright? You cannot say 99 raised to the power 21. It'll be wrong. Alright? Okay, so this was the first law of indices. We'll do the questions later. All right, we'll do the questions later. Let's look at the second law. Second law is very similar to the first law. A raised to the power m upon a raised to the power n is equal to a raised to the power m minus n. Right? Simple. Yes, Kavya, you're absolutely right. That's what you have to do, no, Racine. Or nobody observed that plus sign between those numbers, right? So you've got to be very vigilant. You've got to be very careful. Even in the exams, even while solving the sums, you've got to be very careful. All right. Anyway, so a raised to the power m upon a raised to the power m n is equal to a raised to the power m minus n. Come on. सर आज बहुत सीरियस लग रहे हैं. Okay. So a raised to the power m upon a raised to the power n is equal to a raised to the power m minus n. It's simple. Earlier we had a raised to the power m into a raised to the power n. This was equal to a raised to the power m plus n. And here we have a raised to the power m upon a raised to the power n is equal to a raised to the power m minus n. I hope nobody has a problem with this. Right? So this is clear. This is very simple. Let's move on to the third law. The third law, give the heading, give the point number, third law. Third law, right? So what is the third law? The third law is a raised to the power m whole raised to the power n is equal to a raised to the power m into n, right? A raised to the power m whole raised to the power n is equal to a raised to the power m into n. So if you have 9 raised to the power 2 whole raised to the power 3, so this will become 9 raised to the power 2 into 3 and this will become 9 raised to the power 6. I hope everybody has got it. Say nishten, 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 say nishten, 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 say nishten, nishten, nishten. 9 raised to the power 2 whole raised to the power 3 is equal to 9 raised to the power 2 into 3 and this will become 9 raised to the power 6. Getting it, everyone? Getting it, everyone? Getting it, everyone? So this was the third law. Let's put the point fourth law. What is the fourth law? Thank you, Racine. Thank you, Golden Kumar. Thank you, Ashish. All right. What is the fourth law? The fourth law is a into b whole raised to the power n is equal to a raised to the power m into b raised to the, a raised to the power n into b raised to the power n. This is the fourth law. This is the fourth law, a very simple law. If a into b, suppose you have 2 into 3 raised to the power 9. So this will be 2 raised to the power 9 into 3 raised to the power 9, right? This is the fourth law. You can actually try it as well, right? If I have 5 into 4 raised to the power 2, so this will be 5 square into 4 square. This is the fourth law. Similarly, if I have something like this, a upon b whole raised to the power n, then also I'll have a raised to the power n upon b raised to the power n. So if I have suppose 5 by 4 raised to the power 9, so I'll have 5 raised to the power 9 upon 4 raised to the power 9. I hope this is clear to everyone. It's a simple thing, right? Simple law. And then the last law, the fifth law. Last law. Fifth law is a raised to the power m by n is equal to a raised to the power m whole raised to the power 1 by n, right? It's the same as the third law. This is what the third law was, right? A raised to the power m whole raised to the power n is equal to a raised to the power m into n. So if you open this using the third law, it will be what? A raised to the power m into 1 by n, and it will give you the same thing, a raised to the power m by n. So the fifth law is nothing but just an extension of the third law. Just an extension of the third law. A raised to the power m by n. This is a raised to the power m whole raised to the power 1 by n. So this will become a raised to the power m into 1 by n. This will become a raised to the power m by n. Getting it, everyone? Okay. Great. Okay. Now, all of us know that square root of 3 means 3 raised to the power 1 by 2. Yes, square root of 3 means 3 raised to the power 1 by 2. Can anybody tell me what is the meaning of this? Yes, 4 raised to the power 1 by 3. 4 raised to the power 1 by 3. Can anybody tell me what is the meaning of this? 5 raised to the power 1 by 4. Everybody knows it. 5 raised to the power 1 by 4. Now, understand this. Where is this 1 by 4 coming from? Where is this 1 by 4 coming from? Where is this 1 coming from? Okay, we can see that this 4 is coming from here. This 3 is coming from here. This 2 is understood that over here it's 2. But where is this 1 coming from? Where is this 1 coming from? 1 is coming as a power of the 4. Like 4 power 1. 5 power 1. 1 is coming from here. Alright? Tell you once again. The fifth law is a raised to the power m whole raised to the power, a raised to the power m by n is equal to a raised to the power m whole raised to the power 1 by n. Alright, this is the fifth law. Now, I'm trying to teach you something different, something new. If you have 5 or here and here you have written 4, right? So, you know that this is 5 raised to the power 1 by 4. Now, where is this 1 coming from? 1 is the power of 5. 1 is the power of 5. Right? If I have 9 square, 4th root of 9 square, it will be 9 raised to the power 2 by 4. This 2 is the numerator and this 4 is the denominator in the power. Right? So, if you have something like 5 raised to the power 2 by 3, 5 raised to the power 2 by 3, can you write it as 5 square, and here you can write it as 3 because the numerator is the power of the base and this is the denominator. This is the denominator. Everybody's understanding? Everybody got it. Say nishten, 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 say nishten, nishten, nishten. Right? And this was the end of all the laws of indices. This was actually the end of all the laws of indices. And now we can simply start with the exercise. So let's start. Very simple exercise, very straightforward exercise. Let's see. 4x raised to the power minus 1 by 4. Okay. 4x raised to the power minus 1 by 4. This means 4 into x raised to the power minus 1 by 4. And this means 4 into 1 by x raised to the power 1 by 4. Right? Because we know that if, like, we know that a raised to the power minus m is equal to 1 upon a raised to the power m. right? So a raised to the power n, a raised to the power n is equal to 1 upon a raised to the power n. This we know. Sorry, a raised to the power minus n is equal to 1 upon a raised to the power n. So if we have x raised to the power minus 1 by 4, then obviously this is 1 upon x raised to the power 1 by 4, right? Everybody knows this. So the answer would be 4 upon x raised to the power 1 by 4. 4 upon x raised to the power 1 by 4. The answer will be option C. I hope everybody has got it. Say Nishten, 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 say Nishten, Nishten, Nishten. Very good, Rajat Pandey. Very good, Nandini. Very good, Sananda. Very good, Rajat. Great. Let's look at the second question. Next question. The value of 8 to the power 1 by 3 is. The value of 8 to the power 1 by 3 is. 8 to the power 1 by 3 is. Now, it's basically asking you the cube root of 8. And we all know that the cube root of 8 is 2. The cube root of 8 is 2. Right? All of us know that the cube root of 8 is 2. Now, have I ever told you about calculation of absurd powers? Have I taught you the calculation of absurd powers? I don't remember if I've taught you the calculation of absurd powers or not. If I haven't taught you the calculation of absurd powers till now, have I taught you? I think I've taught you. I think I've already taught you the calculation of absurd power, right? Have I told you how will you calculate the cube root of 8 on your simple calculator? I've already discussed, right? You take the square root 12 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then minus 1, then multiplied with the power, then plus 1, then into equal to 12 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So you have it, right? So this is how you calculate. Once again, Golden Kumar is saying once again, sir, please. Yes, Golden Kumar, I just did it. Alright, but if you'll ask me to go a little slow, then I won't be able to do that because I've already explained it, right? So if you'll watch all the lectures, you'll find it somewhere. Great. Otherwise, it's a very simple thing here. You on this YouTube channel, no? On this YouTube channel, Unacademy CA Foundation. On this very YouTube channel, Unacademy CA Foundation, there's a playlist. There's a playlist. What the hell? Okay, you simply do web series on calculator tricks Unacademy, all right, and here you go. All right, so there are 4 episodes. This is the first episode, this is the second episode, right? This is the third episode, and this is the fourth episode. There's a fourth episode. All the calculator tricks that I'll use throughout the classes, I've explained it in these 4 episodes. All right. So there's also the season 2 also came, but you don't need to watch the season 2 because season 1, these 4 episodes. All right. These 4 episodes which you can see on the screen, these 4 episodes are more than enough. All right. I've already read previous lecture of calculator lecture. Then why were you asking me? Why were you asking to repeat? Okay. Anyway. Right. So next question, question number 3. The value of 2 into 32 raised to the power 1 by 5. 2 into 32 raised to the power 1 by 5. Now we know that 2 raised to the power 5 is 32. Alright. This also we can try. We can check. 2 into power 2, 3, 4, 5. I think I've taught you this also. Right? If you have to calculate the power 5 raised to the power 4, so all you have to do is 5 into, then you press is equal to, this will give you 5 square. Once again you press is equal to, this will give you 5 cube. Once again you press is equal to, you'll get 625, 5 to the power 4. Alright? And the calculator according to me, which is the best calculator, is ORPAT OT 512 GT. This is the best calculator according to me. So this is the best calculator according to me. So you guys can, buy this calculator if you want. ORPAT OT 512 GT. Getting it? So if you want, you can buy this calculator, otherwise no problem. So all the calculator tricks that I'll teach will be working on this this model. All the calculator tricks will work on this model. Okay, great. So 2 into 32 raised to the power 1 by 5. So 32 raised to the power 1 by 5 is again 2. So 2 into 2, this will give you 4. So the answer will be 4. I hope everybody has got it. Say nish 10, nish 10, nish 10. So now question number 3. Question number 3, answer is C. Question number 3, answer is C. Alright, so 1, 2, 3, all C. Question number 4, the value of 4 divided by 32 raised to the power 1 by 5. 4 divided by 32 raised to the power 1 by 5. Now I know that 32 raised to the power 1 by 5 is what? 2. You also know that 32 raised to the power 1 by 5 is 2. So this is basically 4 by 2, and 4 by 2 is nothing but 2. 4 by 2 is nothing but 2. So it's as simple as that. Question number 4, answer should be option B. I hope everybody has got it. Say nish 10, nish 10, nish 10. We'll move on to the 5th question. The value of 8 by 27 whole raised to the power 1 by 3. 8 by 27 whole raised to the power 1 by 3. So we also know that this is 8 raised to the power 1 by 3 divided by 27 raised to the power 1 by 3. We know that it's asking us to calculate the cube root of 8. So the cube root of 8 is 2 and the cube root of 27 is 3. So 2 by 3 will be the answer. I hope everybody has got it. Say nish 10, nish 10, nish 10. Then, right, I hope nobody has a problem with this. 8 by 27 whole raised to the power 1 by 3. So it will be 8 raised to the power 1 by 3 upon 27 raised to the power 1 by 3. 8 raised to the power 1 by 3 means cube root of 8, which is 2, and 27 raised to the power 1 by 3 means cube root of 27, which is 3. We already know this. We can calculate it on the calculator if the need be. Now we'll move on to the next question. Question number 6. The value of 2 into 256 raised to the power minus 1 by 8. Oh my God. 2 into 256 raised to the power minus 1 by 8. Minus 1 by 8. Okay. So this is 2 into 1 upon 256 raised to the power 1 by 8. Now, let's calculate it. 256 raised to the power 1 by 8. 256 raised to the power 1 by 8. The power is in negative. We'll take it to the denominator, so the power will become positive. Alright. Now, 256. 12 times square root 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 minus 1 into the power plus 1 and then into equal to 12 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Right? So 2, basically 2. So 2 into 1 by 2. So the answer will be 1. I hope everybody has got it. Say nish 10, nish 10, nish 10. Say nish 10, nish 10, nish 10. Question number 6, answer will be option A. I hope everybody has got it. Say nish 10, nish 10, nish 10. Say nish 10, nish 10, nish 10. Thank you so much, VA. Yes, Vishal Sharma, option A. S. Jerry is option A. Thank you so much, Nandini Goel. Juttuka, Sai Iswari, 1. Sananda Paul, 1. Pushpraj, option A. Rajat Pandey, 1. Amazing. Question number 7. Let's see. 2 raised to the power 1 by 2 into 4 raised to the power 3 by 4. 2 raised to the power 1 by 2 into 4 raised to the power 3 by 4. 4 raised to the power 3 by 4. Alright, so 2 raised to the power 1 by 2 into 4 raised to the power 3 by 4. We have two options. Either we go by the laws of the indices or we go by the calculator. First, I'll show you how do you go about this kind of question through the laws of indices, right? So 2 raised to the power 1 by 2 into, can I write this 4 as 2 square? I can obviously write this 4 as 2 square, right? So I'll write here 2 square whole raised to the power 3 by 4. Whole raised to the power 3 by 4, and then this 2 will get multiplied by this 3 by 4, right? Because we studied that a raised to the power m whole raised to the power n is equal to a raised to the power m into n, right? Here what do we have? 2 raised to the power 2 whole raised to the power 3 by 4. So this will be 2 raised to the power 2 into 3 by 4. It's as simple as that. So 2 raised to the power 1 by 2 into 2 raised to the power 2 into 3 by 4. This gets cancelled out. And now we have 2 raised to the power 1 by 2 into 2 raised to the power 3 by 2. Now, since the bases are same, the powers will get added. So 2 raised to the power 1 by 2 plus 3 by 2. So this is 2 raised to the power 4 by 2. So 2 2s are 4. So this is 2 raised to the power 2 and the answer will be 4. And hence a positive integer. Here's a positive integer. Yes, Jerry, you are absolutely right. Right? So the answer will be a positive integer. I hope nobody has any problem with this. Maybe I'm moving a little fast. I'll slow it down a bit. Okay. I may be moving a little fast, so I'll slow it down a bit. Don't worry at all. I'm always there. But my hair are not getting set properly. No problem. I'll do it like this only. I will do like this only. मैं तो ऐदा ही करना है करना. Alright, anyway. So this is 2 raised to the power 2 and this will be 4. So let me just repeat it. The question is 2 raised to the power 1 by 2. 2 raised to the power 1 by 2 into 4 raised to the power 3 by 4. 4 raised to the power 3 by 4. Alright. So what I did, 2 raised to the power 1 by 2 into 2 square whole raised to the power 3 by 4. So I did 2 raised to the power 1 by 2 into 2 raised to the power 2 into 3 by 4. So this will be 2 2s are 4. So this will be 2 raised to the power 1 by 2 into 2 raised to the power 3 by 2. Bases are the same. So 2 raised to the power 1 by 2 plus 3 by 2. This will be 2 raised to the power 4 by 2. So 2 2s are 4. So this will be 2 raised to the power 2 and 2 raised to the power 2 is 4. Right? Now we'll solve it on the calculator as well. So just look at how I solve it on the calculator. The answer will be 4 only. See. So first I have 2 raised to the power half. So 2 ka square root. So 2 ka square root and I have put it in the memory. See, I have taken the square root of 2 and I have put it in the memory. Right? Now I'll solve 4 raised to the power 3 by 4. 4 raised to the power 3 by 4. So 4, I'll take 12 times square root. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll do minus 1. I'll multiply with the power into 3 by 4. Then I'll do plus 1 and then I'll do into equal to 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Alright. So 4 raised to the power 3 by 4 is this, whatever there is on my screen, and I need to multiply it with the square root of 2. Now the square root of 2 is already in the memory of my calculator. So what I'll simply do is I'll do multiply and then I'll do MR and then I'll press is equal to, so the answer will be 4.0000. So the answer is approximately equal to 4. Right? Yes. Yes. Bhagwan Sahay Dhanawat, May 21 ka scanner aa gaya. Right? So this is how you calculate it on the calculator. So if you need to repeat it, so you can always rewind the video and we'll move on to the next question. 81x raised to the power 4 whole raised to the upon y raised to the power minus 8. Okay. 81 x raised to the power 4 upon y raised to the power minus 8 whole raised to the power 1 by 4. Whole raised to the power 1 by 4. Right? Can I write it as 81 x raised to the power 4 y raised to the power 8? Right? We know that a raised to the power minus n is equal to 1 upon a raised to the power n. So if we have 1 upon a raised to the power minus n, then obviously this will become a raised to the power this will become a raised to the power n now. Right? It's very obvious. So if you have over here y raised to the power minus 8, like the 1 upon y raised to the power minus 8 will become y raised to the power 8. If you take it in the numerator. So this is exactly what I did. This y raised to the power minus 8 was in the denominator. I took the y in the numerator and the power changes and the power changed its sign. And now this is whole raised to the power 1 by 4. Okay. So 81 raised to the power 1 by 4 into x raised to the power 4 whole raised to the power 1 by 4 into y raised to the power 8 whole raised to the power 1 by 4. Right? 81 raised to the power 1 by 4. I think it's 3. Let me just check. If you have an intuition, no, then instead of going for that, okay, the power 1 by 4 can be calculated as 2 times of square root. The power 1 by 4, like 81 and then 2 times square root, 1, 2. It's clear. 3. right? So power 1 by 4 can be calculated as 2 times of square root. So let me give you another example. Suppose you have 5 into, you have 625, right? And you need to calculate its power 1 by 4. You need to calculate its power 1 by 4. All you do is 2 times square root, 1, 2, right? So if you have this 81, you need to find out the fourth root of 81. So 81's fourth root will be 2 times square root, 1, 2, and this is 3 into this 4 will get cancelled out, like it will be x raised to the power 4 into 1 by 4, and this will be y raised to the power 8 into 1 by 4. This 4 will get cancelled out, 4 2s are 8, so the answer will be 3xy square. The answer will be 3xy square. Alright, the answer will be 3xy square. What? None of these. Yeah. The answer is 3xy square. So, the answer is none of these. Right. Now, question number 9. Question number 9. Let's look at question number 9. It's x raised to the power a minus b. X raised to the power a minus b into x raised to the power b minus c into x raised to the power c minus a. X raised to the power a minus b into x raised to the power b minus c into x raised to the power c minus a. Now, can I write this as x raised to the power a upon x raised to the power b? Of course, I can write it like this, right? Because we studied the 1 upon a raised to the power n is equal to a raised to the power minus n, right? And we also know that a raised to the power m upon a raised to the power n is equal to a raised to the power m minus n. So if here it is written x raised to the power a minus b, then obviously this means that it is x raised to the power a upon x raised to the power b. Then only we can write it as x raised to the power a minus b, like this, right? So x raised to the power a minus b can be written as x raised to the power a upon x raised to the power b into x raised to the power b upon x raised to the power c into x raised to the power c upon x raised to the power a. This and this gets cancelled out, this and this gets cancelled out, this and this gets cancelled out. The answer is 1. The answer is 1. Question number 9 answers option 1. I hope everybody has got it. Say nishten, 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 say nishten, 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 say nishten, 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 say nishten, nishten, nishten. Yes, Bhavya Sarolia, there is a special class today at 2 p.m. We're doing equations and matrices, right? Yes, Rajat Pandey, what you're saying, it started from A and ended also at A. We'll do it a little later. All right, we'll do it a little later. You are absolutely right, but we will do it a little later. Now, question number 10. Just look at question number 10. Question number 10. The value of 2p square q cube divided by 3xy whole raised to the power 0 is. Can anybody tell me the answer? Obviously, the answer will be 1 because anything raised to the power 0 is 1. In the starting of the class only, we saw that anything raised to the power 0 is 1. So, no matter how big a number, how complicated a fraction you give in front of us, and if the entire thing is raised to the power 0, so the entire thing will just come down to 1, right? So 2p square q cube upon 3xy whole raised to the power 0 is equal to 1. It's as simple as that. Now let's look at the question number 11. Question number 11. 3 cube whole square. 3 cube whole square into 4 square whole cube into 4 square whole cube into 5 cube whole square divided by 3 square whole cube multiplied by 4 cube whole square into 5 square whole cube. 5 square whole cube. So this is very simple. In the numerator, this is 3 cube whole square. 3 cube whole square means 3 raised to the power 3 into 2, and this is equal to 6. 3 raised to the power 6 into 4 raised to the power 2 into 3, which is 6, into 5 raised to the power 3 into 2, which is 6, upon 3 raised to the power 2 into 3, 6, 4 raised to the power 3 into 2, 6, 5 raised to the power 2 into 3, 6. So this, and the answer will be 1. I hope everybody has got it. Say nishten, 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 nishten. Say nishten, nishten, nishten. Very good. All right, Bhavya, no issues. Thank you. Great. Question number 11. Yes, question number 11, answer is 1. Jutuka Sai Ishwari is saying question number 12, answer is option C. Okay. Let's see. Which is true? Which is true? Option A, 2 raised to the power 0 is greater than half raised to the power 0. This is obviously false. Why? It says 2 raised to the power 0 and it says half raised to the power 0. We know that 2 raised to the power 0 is also 1 and half raised to the power 0 is also 1. So how can this one be greater than this one? How can this one be greater than this one? Option A cannot be the answer. Option B. Again, this will be 1, this will be 1. So how can this one be less than this one? Option B cannot be the answer. Option C, 2 raised to the power 0 is equal to half raised to the power 0. Option C will be the answer. Hi Mohit Gupta, how are you? Alright, so the answer will be option C. I hope everybody has got it. Say nishten, nishten, nish, nishten, say nishten, nishten, nish, nishten, say nishten, nishten, nish, nishten. Alright, so from question number 13 onwards we'll do tomorrow, and let me just now quickly tell you about the Unacademy website. This is the Unacademy website in which wherein India's top educators help you achieve your educational goals, right? So all you have to do is just click here on start learning, select your goal CA and CS. Then click here on CA Foundation and Intermediate and you'll see what all you'll get on Unacademy's platform. So these are the live classes that are going on right now. These are the live classes that are going on right now. You get to prepare with top educators. You get a lot of batches for syllabus completion and so on, right? In order to access all the batches, you just have to take the subscription for Unacademy Plus. When you'll click here on Get Subscription, you'll see there are two options. We have a Plus subscription and we have a Iconic subscription. In Plus subscription, you get dedicated doubt clearing sessions. You get multiple faculties for the same subjects. You get weekly tests and quizzes, you get a personalized attention, you get colored notes and PDFs, you get structured courses with notes. And in Iconic subscription, other than everything which is there on Plus, you also get a personal coach, a printed books, progress tracker, and a dedicated discussion channel. All right. So this is it. If you click here on Select Plus, if you just click here on Select Plus, so you can see that you can go for either 1 month, 3 months, 6 months, 12 months or 24 month subscription. I would recommend you to go for the 24 month subscription because it includes CA Foundation as well as CA Intermediate. But soon enough, the prices are going to be increased. So now is the right time to take the subscription. And if you put my code over here, NISH10, if you put my code over here, NISH10, if you put my code over here, NISH10, NISH10, and you click here on apply, so you'll see that all the prices will be reduced by 10%, right? All the prices will get reduced by 10%. And similarly, there is Iconic subscription also. So you can take 12 months and 24 months subscription. There's an Unacademy game. There's also Unacademy Combat, which is a gamified quiz competition every Sunday. It's absolutely free of cost. So in order to access that also, you have to use my code NISH10. And there are special classes also which we take every day. And in order to access them also, you'll have to use my code NISH10. Special classes are absolutely free. Combat is absolutely free, but the Plus and the Iconic subscription are paid. And if you use my code over here NISH10, you'll get a flat 10% discount. But the prices are going to be increased soon. So you better take the subscription as soon as possible. I'll see you guys later. Take care. Bye-bye.